A Roman road could survive for 2,000 years. A modern city road can start falling apart before the car driving on it is paid off. That sounds like an engineering failure. But the real difference is not that Roman engineers knew some lost secret. It is that they were solving a different economic problem. Modern roads are usually built to minimize construction cost. Roman roads were built to minimize future maintenance. That one difference changes everything. Because infrastructure is never really cheap. You either pay before it fails, or you pay after. Part 1. The modern road problem. Start with a pothole. At first, it is small. A crack opens in the asphalt. Water enters. Traffic presses down on the weakened surface. In cold climates, that water freezes, expands, and breaks the pavement apart from inside. Here is what that sequence looks like up close. Water finds the crack. It reaches the base layer, the compacted material underneath the asphalt. It begins softening it. The next hard freeze comes, and the water expands with enormous force, prying the crack wider from below. Traffic pounds the weakened surface from above. The surface collapses inward. What was a hairline crack is now a hole. But the hole is not the real problem. The real problem is what is happening around it. The water that created the pothole is still there, still moving, still weakening the surrounding base. The next pothole forms a meter away. Then another. A small defect becomes a larger defect. The larger defect holds more water. More water weakens, more pavement. The cycle accelerates. What could have been a minor repair becomes resurfacing. What could have been resurfacing becomes reconstruction. This is the basic arithmetic of deferred maintenance. A repair that costs almost nothing when caught early can cost thousands once it has reached the base layer and spread. The longer it is ignored, the more expensive it becomes, not gradually, but compounding, because the damage is not waiting. Modern roads are vulnerable to this because many are designed around a short service cycle. Asphalt is relatively cheap to place, fast to repair, and smooth at high speed, but it is not permanent. It is expected to wear out. A typical modern road is not built as a once-and-for-all object. It is built as part of a repeating maintenance loop. Build, patch, resurface, reconstruct, repeat. That system can work if maintenance is funded reliably. But when budgets tighten, road maintenance is easy to defer. The road still exists, cars can still drive on it. The damage is not instantly catastrophic, so the repair gets pushed into the future. The problem is that the road does not wait. Water keeps entering, trucks keep loading it. Freeze-thaw cycles keep expanding the cracks. A budget delay becomes physical deterioration. By the time the damage is visible, the failure has often already moved below the surface. In 2021, the American Society of Civil Engineers gave United States roads a D grade. Not a warning, a D. 1 in 5 miles of highway was rated in poor condition. The estimated cost to fix the backlog, more than $700 billion. That number does not exist because America lacks engineers or money or technology. It exists entirely because of deferred maintenance repairs that were skipped, budgets that were cut, potholes that were left until they became reconstruction projects. The bill was always coming. It just kept getting bigger. That is where the Roman comparison becomes interesting. Part 2. Rome had the opposite problem. The Roman Empire did not need roads because they were convenient. It needed roads because without them, the empire did not function. Legions had to move quickly. Tax revenue had to reach administrative centers. Orders had to travel across provinces. Trade had to continue through rain, mud, and seasonal change. A road that worked only in dry weather was not good enough. A road that needed constant repair crews in remote provinces was also not good enough. Think about the scale of what Rome was managing. Territory stretching from Scotland to Mesopotamia, from the Rhine to the Sahara. Mountains, marshes, deserts, forests, river valleys, all administered from a single city, with no telecommunications, no motorized transport, and no ability to rapidly deploy maintenance resources across 3 continents. If roads failed, military response slowed down, commerce became unreliable, central authority became harder to enforce. So Roman engineers made a different trade-off. Instead of building cheaply and repairing often, they built expensively and repaired seldom. The goal was not a smooth ride at high speed. There were no cars, no buses, and no semi-trucks. The goal was year-round movement for soldiers, animals, carts, and pedestrians. That made durability more valuable than comfort. A rough stone road was acceptable if it stayed usable in all weather. A smoother dirt or gravel path was useless if it turned to mud every spring. So the Romans overbuilt, not because they were irrational, because their operating environment made overbuilding rational. Part 3. How a Roman road actually worked. A Roman road was not just stones placed on dirt. It was a layered system designed to solve one problem above all others: keep the road stable by keeping water under control. Water is the enemy of every road ever built. Not just a risk, the primary cause of almost every road failure. Water infiltrates, weakens the base, freezes and expands, dissolves binders, and erodes compacted material from beneath. A road that keeps water out will last almost indefinitely. A road that lets water in is already failing. Every decision in the Roman road system was made with that fact in mind. First, they dug deep. Construction began not at the surface, but 2 to 3 meters underground. Workers excavated a trench, the fossa, down to stable subsoil. Past the topsoil, past the organic layer, past the frost line, down to ground that does not shift with moisture or seasons. This was weeks of manual labor per mile. Picks, shovels, legionaries, and conscripted workers. No machinery. And it is the single biggest reason Roman roads did not develop chronic settling. Shallow foundations shift as moisture moves through the upper soil layers. Deep foundations do not. Once you are below frost depth, the ground does not heave. Your road does not crack from beneath. Modern roads almost never excavate this deep. The benefit does not appear for 15 years, which is well outside the political horizon of the person approving the budget. Second, they built layers that distributed load. Above the foundation came a sequence of materials, each with a specific job. Large rough stones, the stadamen, were placed tightly by hand, stone by stone, interlocking to create a rigid base. This was not dumped aggregate. Each stone was fitted against its neighbors, often set in lime mortar, creating a mass that transferred the weight of traffic downward and spread it across the foundation. Above that, crushed stone, pottery shards, and aggregate were mixed with lime mortar into a coarse concrete, the rudis. Workers spread it wet and compacted it with stone rollers pulled by animals, multiple passes, eliminating air pockets, sealing the layer against water. Above that, fine concrete, the nucleus was leveled smooth. The final waterproofing course before the surface, dense, impermeable, and flat. The total internal structure was often over a meter thick. It was never meant to be accessed again. Buried infrastructure, designed to function without maintenance for the life of the road. Modern asphalt pavement can be as thin as 4 inches. Third, and this is the part most people miss, drainage. The surface stones were hard, dense, wear-resistant rock, basalt in volcanic regions, granite or limestone elsewhere. Heavy, cut, fitted tightly. But they were not flat. The road surface was crowned highest at the center, sloping toward both edges. Rain hit the center and ran immediately outward. It did not pool, it did not infiltrate, it ran off. At the edges, stone curbs the crepido directed runoff into parallel drainage ditches. In flood-prone areas, the entire road sat on an elevated embankment, the agger raised above the surrounding terrain. Crown, curbs, ditches, embankment. The Romans did not build a road. They built a water management system and then put a road on top of it. When Roman roads failed, and they did, over centuries the failure was almost always traceable to one thing: drainage neglect. Ditches clogged with silt and vegetation. Water had nowhere to go. It pooled beside the pavement, softened the subgrade, the foundation weakened, the surface settled, cracks opened. More water entered through the cracks, reaching the internal concrete layers. The lime mortar began dissolving. The next heavy rain washed out weakened sections. The surface collapsed. The road itself was not poorly built. The immune system had been switched off. Part 4. The hidden advantage: accountability. Construction was only half the system. The other half was institutional. Roman roads lasted because someone was responsible for them. Local communities, landowners, and officials were often legally obligated to maintain road segments. Milestones recorded who had last performed repairs on that section publicly, creating both status and accountability. In Pompeii, archaeologists found wheel ruts worn 15 centimeters deep into basalt paving, and evidence of molten iron poured into those ruts to restore the surface. That repair required genuine craft and deliberate civic investment. Someone decided it was worth doing before the rut became structural failure. This matters because infrastructure does not fail only from bad materials. It also fails from unclear responsibility. If everyone depends on a road but no specific person is accountable for its condition, maintenance becomes easy to delay. That is a modern problem. Road departments know maintenance is cheaper than reconstruction. Engineers know water damage compounds over time. Budget offices know deferred repair becomes more expensive later. But the political incentives point the other way. A new road is visible. A ribbon cutting is visible. A resurfacing project is visible. Preventive maintenance is not. Clearing a drainage ditch is not. Patching a hairline crack before it opens into a pothole is almost invisible. So maintenance competes poorly against projects that voters can see. The politician who approves a cheap road today gets the ribbon cutting. The politician in office 15 years later gets the emergency reconstruction bill. There is no mechanism connecting those two events. No accountability flows backward from the failure to the original decision. Rome had a different incentive structure. A road tied directly to military movement, commerce, and taxation was not an abstraction. If the road in your district failed, the consequences were immediate and local. The feedback loop was short. That did not make Roman administration perfect. Roads still deteriorated. Some were neglected. Some were damaged by weather or political collapse. But the system understood something modern infrastructure often forgets. Durability requires ownership. A road is not finished when it opens. It is finished only when the society that built it commits to maintaining it. Part 5. Why Roman roads eventually failed. Roman roads were durable, but they were not magic. They failed in predictable ways. Clogged drainage was always the first cascade. Water collected beside the pavement. The subgrade softened. The surface began to settle unevenly. Stones loosened. Gaps opened. Water entered through the gaps and reached the internal layers. The lime mortar that had held the rootus and nucleus together for decades began dissolving. Voids formed beneath the surface. The next loaded cart collapsed the surface stones into the void. The pothole spread outward as surrounding stones lost support. If loose surface stones went unrepaired, the sequence accelerated. Direct water entry into the nucleus eroded the concrete rapidly. Once the nucleus failed locally, the surface stones above lost their bed and fell into the expanding gap. Unrepaired ruts deepened through the same mechanism. The depression collected water. The water saturated the subgrade beneath it. Traffic pounded the weakened surface, and the rut deepened faster than the adjacent stone wore down. Traffic then concentrated in the ruts because they were smoother, accelerating wear in exactly the wrong place. When Roman political authority collapsed in the West, organized maintenance ended in many regions. Ditches went decades without clearing. Surface stones were removed for building material. Vegetation moved in. Roots entered cracks and pried stones apart. But here is what happened next, and this is the point. Even when the paved surface was gone, the deep stone foundation remained. Travelers could still walk on the ruined road, still find a firmer path through mud and terrain, centuries after the surface had been stripped away. Because the thing built to be permanent actually was. A poorly built road fails after a few bad seasons. A well-built Roman road could degrade for centuries and still be recognizable. The difference was not that it never failed. The difference was how slowly it failed and what was left when it did. Part 6. Why we cannot simply build roads like Rome. Before you conclude that the answer is just to copy Rome, stop. Roman roads were extremely durable inside their design envelope. The problem is that modern traffic is outside that envelope entirely. Roman roads were designed for Roman traffic, pedestrians, horses, carts with iron wheels pulled by oxen. The heaviest axle load on a Roman road, a fully loaded military supply wagon, was measured in hundreds of kilograms. A modern semi-truck has axle loads measured in tons. Here is the physics that makes this decisive. Pavement damage scales with the fourth power of axle weight. Double the axle load, and you do not double the damage. You multiply it by 16. An axle load 10 times heavier than a Roman cart does not do 10 times the damage to a road surface. It does 10,000 times the damage per pass. A single loaded freight truck can impose stresses completely outside the design world of Roman roads. A Roman-era stone surface would deteriorate quickly under sustained modern freight traffic, not because it was poorly built, but because it was built for a completely different world. Modern roads also need to be smooth. Hard basalt blocks are extraordinarily durable. They are also deeply uncomfortable at highway speed. A cart moving at walking pace absorbs the roughness. A vehicle at 100 kilometers per hour cannot. Modern materials are specifically engineered for smooth, high-speed surfaces. That is a different trade-off than stone block construction offers. And modern roads need lane widths, turning radii, intersection geometry, buried utilities, accessibility standards, and traffic volumes that Roman construction was never designed to handle. So, the Roman road is not the answer. But the Roman principle is. Roman roads are often used as a simple contrast. Ancient roads lasted, modern roads do not. But the deeper lesson is not ancient superiority, it is life cycle thinking. The Romans matched their construction investment to their maintenance capacity. Their maintenance capacity in distant provinces was near zero, so their construction investment was extremely high. They built once and built to last, because they had to. High upfront cost, very low life cycle maintenance, very long service life. The system was internally consistent. Our system is also internally consistent, but in the wrong direction. Low upfront cost, high ongoing maintenance, short service life. It would work if the maintenance actually happened, on schedule, with adequate funding, before small problems compounded into large ones. It almost never does. Budget cycles run on 4-year political timelines. Infrastructure runs on 25-year engineering timelines. Those cycles are structurally incompatible. We know durable infrastructure costs more upfront. We know preventive maintenance works. We know drainage determines pavement life. We know heavy loads accelerate damage. But knowing something is not the same as funding it. The failure is not knowledge. It is incentives. We keep making the same trade. Cheaper now, catastrophically expensive later. Rome is gone. The roads are still there. Not because the Romans were smarter, not because they had better technology, but because somewhere, a long time ago, someone decided that the road they were building mattered enough to build it right. We know how to do that. We just keep deciding it costs too much. 2,000 years from now, nothing we have built will still be a road. Not because we lack the knowledge, not because we lack the materials, because we decided, year after year, budget cycle after budget cycle, that the future could pay for it. The future always does.